this assessment, we're asked to rank the CH sigma bonds on the basis of their bond length, where 1 is longest and 3 is shortest. Now, when we look at these, all of them are carbon-hydrogen bonds, but we notice that this one here on the left is a bond between an sp2 hybridized carbon and hydrogen. The one in the middle is between an sp hybridized carbon and hydrogen, and the one on the right is between an sp3 hybridized carbon and hydrogen. And so hybridization appears to be the issue that's differentiating these bond lengths. Well, what does that mean? An sp hybridized carbon is going to use an orbital that has 50% s character. The more s character that's in the bond, the closer that bond is going to be held to the nucleus. And so the sp hybridized CH bond is going to be the shortest. Moving over, sp2 is going to have 33% s character in the bond, and so it's going to be the second shortest, or number 2. And then the longest bond with only 25% s character, that bond is going to be held farthest away from the nucleus. It will be the longest bond.